94 in the 3B section. Skier squats low and races down an 18-degree slope. During a 5-second interval, skier accelerates at 2.5 meters per second. What are the horizontal and vertical components of their acceleration during this time interval? So this is their overall acceleration. They have some acceleration sub y. They have some acceleration sub x. Yes? And that's what we'd like to know. We'll go with a different color. So this angle is, oh yeah, okay, hold on. So this angle is 18. What's that angle going to be? Complement of 18. So 59, 60, 90, no, 69. 72. We'll get it yet. Okay, so this is a 72-degree angle. The other angle we can use is this one, which would be what? 18. So it doesn't matter which you use, you just have to know that your opposite and your adjacent are going to be different based on which angle you use. And you know what, we'll go ahead and use the 18 that's given in the problem, but I do want you to realize that you can always use the complement, and we do spend a lot of time figuring out complements to angles. When we get into some of the force problems, you spend the first 5 minutes just figuring out all your angles. Okay, so the y display, the y acceleration is going to be our delta, or our y axis. What trig function connects the hypotenuse and the opposite? Sine. So we'll start off with our sine of theta equals opposite over hypotenuse. In that case, it's going to equal our y acceleration over our acceleration. Okay, so sine theta times acceleration will give us our y acceleration. Okay, sine of 18 degrees times 2.5 meters per second squared will give us our y acceleration. Now here's a question I have for you. Is this going to be a positive or negative acceleration? So are they going down the y-axis or up the y-axis? Down. They're going down. So, and your book, yeah, your book gives this as negative. So the number we get, the absolute value, is 0.772542486 meters per second squared is our y acceleration. And we know that that's going to be a negative because they're headed down on the y-axis. We can have how many sig figs? Just 2. So negative 0.77 meters per second squared is our AY. Write that. Okay. So now let's go ahead and we'll do our A sub x. We'll do A sub x in red, assuming that works. So what function connects adjacent and hypotenuse? Cosine. So the cosine of theta is equal to A sub x over A, because it's equal to adjacent over hypotenuse. Okay, so the cosine of theta times acceleration will give us A sub x. Cosine of 18 times 2.5 meters per second squared will give us A sub x. So we get 2.377641291 meters per second squared is a sub x. We can have 2 sig figs, so that's 2.4 meters per second squared. Now, the way I happen to draw this, which was just my own thing, is that x acceleration positive or negative on an x-axis? Traditionally. We're heading, yeah, okay, you know what, we could be. I'm visualizing origin over there. So it's positive. Could you draw it the other direction? Yeah, you could. And it would depend on how you presented it. So in this, you can't really answer the sign question without the picture. So yeah, in this case, we're heading in a positive y, so or positive x, so that's going to stay positive. Okay. Questions? Okay, we'll shut this down.